Okay, so in the last session, we have discussed about the framework called OpenCV, which is for computer vision application. And today, I have posted a job opportunity regarding the same. Let me just share with you a company in Kerala. It's actually a robotics company who are looking for OpenCV developers. Okay, so I have shared, for two reasons. One is that there are people who are experienced in OpenCV and all in the server, Discord server, and also you guys will get an idea what are the requirements, general requirements that you have to satisfy in order to get a job in computer vision or robotics. Okay, and also I got an opportunity. This company I personally know. They actually send me this requirement, so they are looking for a ROS developer mainly, and the requirement is actually mentioned in this PDF. Okay, the package is around, it's based on the experience, like ranging from 5 to 10 basically. Okay, so these are the two new job opportunity that I have. And also I mentioned that about the Asimo Robotics, they are also looking for ROS developers. Okay, so OpenCV is one of the library that we will use in robots. Okay, so we have seen the fundamentals of that. Okay, today I'm planning to discuss about the PCL library, which is again a library for doing 3D 3D vision. Okay, 3D vision. OpenCV is mainly handling 2D images, okay, from the camera, but PCL library is mainly handling 3D point cloud data from the depth sensors. Okay, I will explain that. And then I'm just planning to jump into the Git, okay, which is actually I think you may know about Git, but I just want to discuss about Git a bit. Okay, and we can see how to create a Git repository. Then we have to create a Git portfolio before starting the projects. Okay, so the objective of this course is to create a project portfolio in Git. Okay, maybe I can just share some portfolios from the previous course. Let me just check. Okay, so one is France. So you can see this kind of portfolio, like when you take this repository or his profile, then you can able to, oh, just a sec, I posted in the wrong channel, just a second. Yeah, let me check. So you can see his work, okay, that is done as the part of ROS developer course 1. Okay, so these are the project, and this was the famous one, and I also mentioned this project in my book, Mastering ROS for Robotics Programming, 3rd edition. He actually contributed one chapter. Okay, so you can see his contribution in Git. Okay, so this means that he's very active in coding. He's active in the ROS ecosystem. So this is the project. Okay, diff board, and you can able to find this project. It is having 105 stars, and yeah, it's pretty decent project, and you can take it as a reference for building differential drive robots. Okay, even I am actually using it. Okay, so that was the main objective of this project. Just create a template project so that you can simply take it and you can modify. Okay, yeah, so this actually the project that done as a part of this course, and he's actually mentioned this here is acknowledgement. This was the first course. Okay, yes, so so that is the objective. You also have to contribute like this. Okay, so during hiring you can simply show this repository, your repository or your portfolio to the company, and they can understand. Obviously you are contributing contributing to the open source community, and that actually indicates that you are an active developer. Okay, so that is objective. So Git is actually an important part of our course. Okay, yes, so let's start with the PCL first. Okay, so anyone work with the PCL before? Point Cloud Library? Anyone work with PCL? PCL library? I mean Point Cloud Library, that is actually the PCL. Anyone worked? Okay, fine. So maybe it may be a new thing for you, but I'm just sharing the official website of PCL here. Okay, and it's actually a very interesting library. Okay, while comparing with OpenCV, I really like the PCL. The thing is that in OpenCV we are handling the 2D image, right? But in PCL we are handling the 3D data. Okay, for example, you may have seen the self-driving car, right? Maybe I can show you that self-driving car LiDAR. Yeah, so some of you are already done a course in self-driving, I mean in self-driving car. So you can able to see this is a car, self-driving car, and there is a rings around the car, right? It's actually the output of a LiDAR which is mounted on the top of this car. Okay, so one of the popular LiDAR is Velodyne. Okay, and currently there are a lot of competitors for Velodyne. So you can able to see, just a sec, you can able to see a lot of I mean sensors on the top. Just a second. Yeah, maybe I can open like this, open image into it. Yeah, you can able to see on a self-driving cars there is a sensor on the top, right? And there are cameras, and I mean it's a combination of many sensors mounted on the top. So this thing, okay, this thing is the LiDAR, okay, which will spin. Okay, there are models which is not spinning and which is spinning, and that LiDAR, okay, that LiDAR is actually giving these 3D data. Okay, we are calling this data as point cloud. Okay, cloud, you know cloud, right? What is a cloud? It's a 3D thing. So point cloud means it's a cloud of points, simply. So it's a 3D point basically. Okay, so when you combine a group of points in 3D, then you will get a cloud. Okay, so like this. So if you see these things around the car, basically it's individual points, but there are many points. Okay, so the LiDAR, which is actually returning with many points, maybe 20,000, 30,000 points around the robot. Okay, and what is this point about? It's about the range or obstacle. For example, if there is a person in front of this car, then this LiDAR can give the obstacle. I mean, like this. You can able to see here. So around this car there are a lot of people, and you can see the 3D value. I mean 3D range value. So these all are obstacle. So the LiDAR will detect this obstacle, and you can see it is in 3D. Okay, LiDAR is rotating 360 degree. Okay, it's continuously rotating, and it's actually putting lot of laser points into the environment, and when it returns it will get the distance. Okay, basically it is detecting the obstacles around the car, and this obstacle detection is happening on 3D. Okay, so this is one of the very popular technology now. I mean, even if you are going with like masters, for example, mostly you will be ending up in a self-driving car company, because there are a lot of opportunities in self-driving. I personally know, because I had an opportunity to work in CMU for a while, and there are a lot of startups in self-driving, and I also seen a self-driving car. Okay, I think there is a company called Argo AI. So it's based on Pittsburgh, and these cars actually like roaming around the Pittsburgh city to collect data, 3D data. Okay, so yeah, so this is they have many models. Okay, you can see the lidar on the top. Okay, if you take any self-driving cars, mostly the common thing is the lidar on the top. You can able to see here. Okay, and not only one lidar, they are using two, and also there are many cameras and all. Okay, so it's like a helmet a helmet on the top of the car. Okay, but it's doing a lot of sensing, and that thing is feeding into a computer inside the car that is actually doing all the processing. Okay, so what I mentioned about self-driving car was, if we get the 3D information, okay, from these sensors, or we are calling as a 3D information as 3D point cloud. Okay, so if you search in Google about 3D point cloud, you will get this. I mean, you can see here, right? The environment around the robot is actually getting as a group of points, okay, in 3D. So you will be like getting the exact shape of the environment in 3D. Okay, so if we have the 3D data around the robot environment, then you can do a lot of stuff like obstacle avoidance, then path planning, then pedestrian detection. I mean, many stuff. Okay, so you can I mean, you may have seen the self-driving car video. There are many videos available in, I mean, from Waymo and all. Lot of videos are there, but not able to check it. Just a second. So you can able to see what are the things it is doing. As of now, I couldn't able to find any, but it's there in YouTube. Yeah, I think this will be fine. So this was the one of the first company who introduced the self-driving cars, Waymo, which is a spin-off from Google. It was actually the part of Google, then they actually spin off from Google. So you can see the robot. It's called the robotic car, and the steering is rotating automatically, and you can see the top sensor, which is actually properly shielded, and all these path planning and everything is doing automatically. Okay, so one of the important library that we are using in self-driving car is PCL. Okay, why? Because the main sensor of self-driving car is lidar, and what lidar gives to us is the point cloud. So the point cloud library is doing the processing of PCL, I mean point cloud basically. Okay, so now you got the importance of the PCL library, right? So the PCL library, again, it's actually I mean, a lot of work happened in Willow Garage. Okay, and currently it's open source. You can modify it, and it's also supporting cross platform. It is working in Windows, Linux, Mac. Okay, and it's written in C++. Okay, I think there is some Python extension, and this is a base paper of PCL. Okay, it's basically they presented this paper in ICRA 2011, I guess. Okay, 2013. Okay, so Steve Cousin, which is he's actually from Willow Garage. So this is a base paper of PCL, and you can find it's from the Willow Garage. Okay, so those guys are like started the PCL. I think they have done a lot of work in PCL, and you can see the base paper. I'm just sharing the base paper, so you will get much idea. Okay, so the fundamental objective is to like represent an object in 3D. Okay, so in order to represent an object in 3D, you need to use this kind of some kind of data structure, right? So the PCL, the point cloud, is actually one of the representation that we can use to hold a 3D environment. Okay, so that is about the point cloud. Like, it's mainly developed in Willow Garage, and like OpenCV, there are many modules available. Okay, there are many modules available. There are modules for filtering the point cloud. For example, the point cloud is actually a big chunk of data, and you may have to apply filters to reduce the noise, and then to eliminate some range of obstacles. You can do a lot of things because it's a chunk of data, and you can detect pedestrian from the point cloud. Okay, using some 3D object detection, you can find it. Okay, you can find features of this point cloud. Okay, and from that you can calculate odometry. Okay, like that, there are many things. You can even map the environment using point cloud. Okay, so there are many applications of PCL, and all these things are like available in the sub modules. Okay, from the word itself you can find like filters, segmentation. Segmentation means like segmenting some part of the point cloud, and the IO means interfacing the depth camera or like 3D lidars. Okay, so these are in the IO modules. And I think you know about the depth camera. If not, maybe I can give a short introduction. So the depth camera is again a 2D by 3D sensor. Okay, basically a depth camera is having a normal RGB camera. Okay, normal RGB camera and a depth camera, meaning there is a thing called IR projector. Okay, IR projector. So this IR projector, what it does is that it will project the IR points into the environment or into maybe a room. If you are in a, if the things are happening in a room, then it will project small point like this. You can find these points, and then these IR points will return, and that time will be calculated, and the distance of the obstacle or object is calculated. Okay, so the fundamental objective of this IR camera or like this depth camera is giving delivering the 3D data of the environment. Like maybe I can show you depth camera point cloud. If you check, if you get the 3D information from the environment, then you can create the point cloud. Okay, so this is a point cloud. Okay, so what I'm trying to say is the depth camera are one source of getting point cloud. Okay, and how it is calculating or creating the point cloud, it's using the IR camera IR camera and IR projector. Okay, and also we can compute the point cloud using stereo vision. Okay, for humans we have two eyes, right? So we are using the stereo vision techniques to compute the depth. Okay, using that we can do the IR projection is actually very accurate. Also the laser based IR laser that is using in Velodyne or like LiDAR, that is also accurate. Okay, so these IO modules are for like interfacing the depth cameras into PCL. Okay, so there are other libraries for interfacing, but there is a module for interfacing the IO. Okay, then registration features for tracking features. I'm not aware of all the modules, but it's like processing the point cloud basically. Okay, so that is the point cloud library, and the fundamental things that it is doing is it can hold a point cloud, it can pre-process it, process it, it can during processing it can detect object, then filter, it can do a lot of stuff. Sorry. So these are the things that a point cloud library can do, and if you are a student then, and if you are interested in participating Google Summer of Codes, then I think point cloud library is there, even Rose was there. So you can contribute to some of the modules, so like you can involved in this kind of open source development. Okay, so I am also entertaining the open source contribution from you, because that is also a that can be included in the portfolio. For example, if you contributed something to OpenCV, you can put that in your profile. Okay, and if you contribute in PCL or ROS, that is actually very valuable. Okay, that's what the universities and companies are looking for, because they have to know like you are active in development, or like you are active in I mean, an open source contribution is very valuable actually. Okay, so I mentioned that PCL is an open source project, and this is the official website or like GitHub link for PCL. Okay, you can see it's a very popular project, like 7.1K, not compared to, I mean, not very popular as OpenCV. Let me check the OpenCV stars, which is like 60K. Okay, yeah, the difference is actually very high, but still, I mean, it's a very popular library. Okay, PCL, this is a source code of this library. Okay, and it is compatible with 20.04. You can install it from Ubuntu packages, or from compiling the source code. Okay, like that we have done for the OpenCV. Okay, the compiling instructions are the same thing, like you have to I mean, clone the repository, then using CMake you can build it. Okay, and for installing from the source code, or from the binaries, you can use a Synaptic Package Manager, and I will prefer like not to install PCL. I mean, that is fine, but it will be already installed along with ROS. Okay, so no need to worry about OpenCV and PCL installation. It will be automatically installed. So we have the libpcl, just a second, I think it's the libpcl dev. Yeah, so if you install this package, then all the dependencies of PCL will be installed. Okay, libpcl dev. I mean, if you are planning to work only with PCL, I think if you are not planning to install ROS, then you can simply install apt install this one, and it will install the PCL library. Okay, the version is 1.1. But if you're planning to, I mean, if I already installed the ROS Noitic, so if I search for ROS Noitic, you can find there is a package called PCL ROS. Okay, so if you install that, then it will install all other dependencies of PCL. Okay, so that's why I mentioned if you install desktop full installation ROS, then it will also install OpenCV and PCL. Okay, so that's how we can install PCL quickly on Ubuntu. Okay, and now I just want to show you a demo. Okay, after that I will explain the code. Mainly the PCL code is written using CPP. This is a sample code. Maybe you can say it's a hello world. I'm not going deep, but I just want to show you like how the code looks like. Okay, so basically first I will show you the compilation steps. Okay, using CMake. Then we can see how it is working. Okay, how the code works. So basically I have a code called PCL test, and I'm sharing the link for doing this. So for PCL library, there is a good documentation available. So if you just go to the PCL website, and then if you go to the tutorials, you will get a nice tutorial website. Okay, I'm just sharing it, and about the data structure and about the projects, everything is there in the tutorial. So first they are starting with the modules, different modules inside PCL. So we have seen like filters, feature tracking, then IO, then visualization. So these are the modules, and you will get a good overview of PCL from here itself. Okay. So so the overview is basically about different modules inside PCL. Okay. So after that, you can go into the getting started basic structure. So this will be like teaching you how, what is the class which we are using to hold a point cloud. So if you remember, in OpenCV we have used the mat class, right? CV mat. In PCL we are using PCL point cloud class. Okay, I will get back to that. And then they are like showing the first project. Okay, how to start with the first project, and this is what we are discussing now. Okay, so they are mentioning a code and the CMake configuration. Okay, so here is a code called PCD write. Okay, and this is the CMake configuration. Okay, so I will just try this and then I will explain. Okay. Okay, yes. So I just created, or I just copy pasted the CMake list. I mean, you know how the CMake list looks like. Basically, we need a CMake minimum version, and there is a project name, then find packages. So this is what we have seen with the OpenCV. So here we are saying like we need the PCL version. 1.2 version is the required one. Okay, minimum, I think minimum 1.2, or like yeah. So you can mention which version that we require. Then include directory on the PCL include directory, link. Okay, link directory. Then basically we are creating the executable and linking with PCL libraries. Okay, I mean OpenCV building and PCL building is almost the same. Okay, basically we need to find the package and just create the executable. Okay, so it's not a big deal, and the source file is pcl-test.cpp. Okay, so you know how to build it, right? Just create a build folder. I already built it. Okay, and I'm just removing this. I'm just okay, so this is a build folder and I'm executing CMake space double dot. Okay, so now it will look for the PCL, and it seems like it's found PCL. You can see the messages here. It's found PCL, and everything is good. Configuring done, generating done. Okay, so now what we have now is the make file, right? So now the steps are clear. Just do the make, and then you can see the message like it's building PCL_test.cpp. Okay, so it will take some time, and now linking, and then if you check it, we have the executable called PCD write. Okay, now just execute it, and then you can find it's I mean it's actually printed some values. Okay, and then if you check ls, you can find a .pcd file. Okay, so the .pcd or point cloud data file is basically can save a PCD value. Like we can save the image in JPG, PNG, or like TIFF or any format, right? So like that, one of the format that we are using to save a point cloud is .pcd. Okay, which is compatible with point cloud library, and if you open it, you can find this file. Okay, basically it is having some configuration. Okay, like it is having some fields, type, count, width, then points, then data ASCII, and these things are the 3D points basically. Okay, so X, Y, and Z. Okay, so that's what these points indicate. Basically, in the point cloud data, we need the three data, right? X, Y, and Z. Okay, that is the 3D point. So the orientation doesn't matter because it's a point, right? So orientation doesn't matter. And so these are the points that the file is having, the PCD data is having. Okay, so what happened was, when you execute the PCD write program, what happened was, it's actually created a PCD file which is having 5 points. Okay, it's writing 5 points, and it's stored as a file. Okay, so that's what happened when you executed the PCD write. Okay, so now jump back to the code. Okay, PCL test, and now this is a code. Okay, so no need to worry about, like, if you don't understand anything. I mean, these classes or something, if you don't understand, that is pretty fine, but just make sure you got the flow. Okay, I can explain the flow. So I'm just comparing with OpenCV. So while discussing the OpenCV, we have used the mat class, right? Mat class for holding an image. Okay, we actually created an object of mat class, and then we have used the IM-read, or like any streaming video, or like camera we have used, and then we were been manipulating the images using mat object. Okay, so when compared with OpenCV, in PCL we have a class called point cloud. Okay, and the namespace is PCL. Okay, so I'm not explaining what is a namespace, you already know. So when you work with PCL, we need to include the header files. Okay, so this header file, this is for if you want to write a file, then we need to use PCDIO, and also if you want to interface into some cameras, depth cameras, we need the IO modules. Okay, so that is what we given here, PCL/IO. Okay, and also this is for the data structure, for getting the PCL data structure. So there is a difference here when we compare with the OpenCV. So in OpenCV, we have seen there are different kinds of images. Like there is a RGB image, there is a grayscale image, there is a binary image, right? So in order to handle all kind of images, we are using mat object. Okay, mat object. But in point cloud, what we are using is, it's not a regular class, normal class. It's actually a template class. In C++, I have explained about a template in C++, right? Maybe I can just show you, like a template class in C++. Okay, templates. So any idea about templates in C++, guys? Templates? Anyone remembering what is a template is in C++? Okay, maybe I can explain. The thing is that if you want to create a class, okay, if you want to create a class, and if you want to make that class as generic means it should work in all data type or something like that. Okay, for example, if you are writing a calculator program, for example, there can be different kinds of numbers. Like there can be integers, okay, there can be float, there can be double. Okay, so these three variation can be there, or many variations can be there, imagine. So if you want to write a program or write a class or function which is working for all kind of values, okay, all kind of value, or like maybe define for like 10 or 5 kind of value, then we have to use templates. Okay, I think from the word itself, the template is actually like that template can be used for different kind of data. Okay, so if you write a calculator template class, then using that template it will work with normal integer, float, then double. I mean, I'm saying an example, so to give an idea. So that's what the purpose of template class. Okay, templates are for making a function or like a class generic, and the template class you can give what kind of point cloud we need. Okay, so that means there are different kinds of point cloud available. Maybe I can show you that. Types of point cloud PCL. Okay. Let me just go through it. Point T. Okay. Let me check it. Yeah, so this is what I am searching for. So I mentioned that the point cloud is a group of points in 3D, right? So there can be different kinds of point cloud. So I can say one point cloud which is only having X, Y, and Z. Okay, only having X, Y, and Z, and these points can have colors, right? Imagine in a 3D environment. Okay, in a 3D environment, the point cloud, these individual points can hold a color as well, right? Okay, so but in XYZ, this point XYZ, let me take the example. Just a sec. Colored point cloud. So here what you are seeing is a colored point cloud. Okay, here you are seeing it's a 3D value. It's a 3D point cloud. Okay, and you are seeing the colored one. Okay, that means individual points are holding a color like the image. Okay, so that is what the registered point cloud, or like the point cloud having the color, that is RGB value. Okay, but there are point cloud that doesn't have any color as well. Okay, only having the XYZ value, and we can give colors. We can give like some colors to it. Okay, so here what we are using is PCL point XYZ. Okay, so this point cloud doesn't hold any color, only the distance value. Okay, so that's what we got here. Like you have seen the PCD file, right? So it is only having the XYZ value. Okay, maybe I can just show you that. So only having the XYZ value. Okay, but there are different kinds of point cloud. So one is let me take point XYZ RGB, point XYZ point XYZ RGB A, meaning there is an alpha, the transparency is also there. Okay, so in a point cloud you can have the 3D value, you can have the RGB value, you can have the RGBA value, then there is a RGBL. I'm not familiar with that. So that means we can define, I mean, 4 or 5 kind of PCL. Okay, 4 or 5 kind of PCL data. Okay, so this point cloud class should be able to handle all kind of point cloud type. So that is why we are using the template. So here this is what the template is. If you replace the point XYZ with RGB, then this cloud is an object of this point cloud class, which will be having XYZ and RGB value. okay, which can hold XYZ in RGB value. Okay, so that is the first thing in a PCL program, which is basically like creating an object which can hold a PCL data. Okay, and normally when you work with robots, you will have a camera, depth camera, or a lidar or anything, which is giving us with which is giving us the point cloud data in the form of this point cloud object. Okay, point cloud object, cloud object. Okay, then what you can do is you can just pre-process, or you can process the cloud object like there are many functions inside this cloud class. Okay, so if you just check the PCL point cloud class, this is the definition, or this is the detailed documentation of PCL point cloud class. So you can find there are many functions inside the point cloud class in order to manipulate the PCL. Okay, so so that is what the point cloud class is. Okay, and from the object, point cloud object, you can set these parameter, width, height of the point cloud. Then if it is dense or not, then you can resize. These all are some basic functionalities inside the cloud object. And basically what we are doing here is we are creating a new point cloud. Okay, so we have defined the width and height of this point cloud, and then we are writing some random values to this point cloud. Okay, after that we are saving this point cloud in a name like test_pcd.pcd. Okay, so these all are the functions inside the point cloud library. Okay, so this is what happening in the hello world program. Okay, here we are like reading from the cloud. Okay, we are just printing different points in the point cloud. Okay, so the flow is that defining the cloud object, then here we are like writing into the cloud, we are creating a new point cloud. But otherwise the flow is like from the existing point cloud we are doing some processing. Okay, we are like we may do some filtering. Okay, so there are some filter function in PCL, so we will pass this cloud object to filters, then we will do some segmentation. Okay, all these things can be done. Okay, so I have some examples with the ROS APIs, but I'm not explaining this that code now because you will have some confusion. But just make sure you have understand this stuff. This is a important part of the point cloud program. Basically creating an object, then you can read a point cloud, then you can like process it. Okay, so this is what happening in the point cloud library basically. And in the tutorials they have documented everything. So I prefer you to use the documentation, official documentation. They actually mentioning about installation, which is we don't need. Then how the 3D features, point features, there are many examples as well. And from the repository I think we will get some examples. Point cloud library. From the GitHub I think there is some samples available. Yeah, here are the examples. So you can find the examples like OpenCV. In OpenCV you have seen many examples, right? So like that you can find these examples from PCL as well. Sorry for that. So there are filters examples, so you can build these projects using CMake. Okay, so you can simply go through these examples. So basically you can find the cloud object. Okay, and there are two ways to use the cloud object. One is like creating an object, or one is through the pointer. Okay, just a second. Let's through one is through the object, like we are creating a copy of the point cloud class. But if you are working with a big point cloud, the better thing will be working using pointers. Okay, so that's why they're using cloud type pointers. Okay, here you can find we are creating a pointer for our data, and then we are working based on the working using the point cloud pointer. Okay, so that will be much faster compared to creating a copy and do. Okay, because we are getting point cloud data, which is a chunk of data like 2 MB, 3 MB, 3 MB data. So that should be processed in real time. So in order to do that, one of the best ways to handle through pointers. Okay, so this is an example for filtering, and so I'm just showing this, but the real thing is there while working with rows. We need to see how to interface a point cloud library to rows and all. Okay, so I'm just going through the basic examples for point cloud now. You can look onto it. Okay, so fundamentally you can find everything is based on the point cloud class. Okay, in order to work with the pointer, you can create a pointer like this. Okay, PTR, and then you can work with the pointer. Okay, compute normal. So these all are the APIs of the PCL. Okay, so yeah, so it's simply the work of the APIs. So if you know the PCL APIs, for example, PCL API, you can easily do this. Okay, and also I'm saying like each library is actually very vast. Okay, so these are the APIs of PCL. Okay, you can find how big it is. Okay, so if you just go to the point cloud, just a sec, the point cloud class, basically you can find the point cloud. I think the definition. Yeah, I mean all the modules are there of PCL. You can simply go to each modules and find the APIs of PCL. Okay, yeah, so there are many functions. So yes, so that is what the PCL is. It's simply a C++ library which is having many modules, and then there are many examples programs, and the fundamental thing is understanding how the point cloud class works. It's a generic class. You can hold a XYZ, I mean simple XYZ point cloud, XYZ RGB, XYZ alpha, everything will support. And then you can pre-process or process the point cloud with the PCL APIs. Like you can filter it, you can segment it, you can save it, you can like edit it. I mean all up to you. You can learn these APIs and work with it. Okay, and also there are a lot of opportunities for point cloud developers, point cloud library developers. So like OpenCV, there are many opportunities, especially in the field of self-driving cars. Okay, so if you are planning to work with some self-driving car company, one of the skills that they are looking is the PCL, especially if you are working deep learning, vision stuff. Okay, so the vision is an important part of self-driving because all the things are working based on vision. So if you are planning to work on the deep learning part, I think PCL skill is required. And also if you are planning to go for masters, that also I will prefer you to learn PCL, because for example, if you are working with a object manipulation, okay, I'm just concluding with PCL and I'm just giving some examples. So PCL is not only used for autonomous cars, but just check the case of object 3D object grasping using robotic arm. Okay, so this is an interesting area. You can basically the objective is like grasping an object in 3D. Okay, so if you put a object, I think this is happening in CMU. Just a second. Okay. Yeah, so no, it's not in CMU, but in NVIDIA, I guess. Okay, so maybe I can just show you this video, which is using the 3D object detection. See, the objects are detected as 3D, and you can find a a detection around this object, and that input is actually feeding into the robotic arm, and the robotic arm can decide, or it can compute the grasping pose. Okay, grasping pose means in which pose should the robot approach to the object and grasp it. Okay, so these all are like there are 2D image processing based detection, also 3D. Okay, so these kind of work are like doing in the grasping field. Like if you are working with robotic arm, you may encounter this 3D stuff. Okay, so you can find a grasping pipeline here, robot plus RGBD camera. Okay, and we have the RGBD data, which is RGB means the normal image, and D means the depth. Okay, so the depth camera. Okay, so if we have the depth camera information, we can do the object detection, then the grasping, motion planning, and execution. Okay, so while working with the motion planning of the robotic arm, that is very important. And also if we want to do the 3D mapping in mobile robots, we can see the R-tab mapping, which we will discuss in our course, which is actually using the point cloud. Okay, so it can basically map the environment in 3D, which is using the point cloud. Let me check where it is. In the official website also it is there. Maybe I can just show you that. Tab rows. So like that, there are many applications using point cloud. Here there is a mapping demo. Maybe I can just play it. You can find the robot is moving, and it is having a laser. Okay, it is having a laser, and using that laser it's creating a point cloud, and not only creating, it's mapping actually. Okay, so using the features, it's actually creating a map, 3D map basically, and calculating the odometry. Odometry is the position of the robot with respect to the map. Okay, so we will see these examples in our course. Okay, R-tab as well. Okay, so these all are like using the point cloud, then images, fusing of all this data. We can make use of images, point cloud, and all this stuff to create a 3D map of the environment. Okay, so yeah, so these are the main advantages of learning OpenCV and PCL. Okay, what I have taken was like the basic stuff, only an introduction. Okay, but just understand that like these are I mean, we can do a lot of stuff using PCL, and the rest of the things like the interface of OpenCV and PCL to ROS we will be discussing in the ROS session. Okay, after discussing the prerequisites, we will go to the serious topics. Okay, so now it's a time for Q&A. We couldn't start with Git, so you can ask questions like if you have any confusion with the PCL library, okay, the basic one. So if you have any doubts to like how to install it, how to set up a PCL project in C++, you can ask me. Okay, so it's actually very similar to OpenCV, but the data that we are handling is different. It's 3D. Okay, and working using 3D data, it's not easy in the sense in image we will have, I mean, more points, I will say. Sometime we will not, maybe the images may be affected by noise sometime, and sometime the resolution of the image will be less. Okay, but in point cloud, especially the point cloud from LiDAR, it will have a lot of noise, and also the resolution is not much higher than these images, in the sense the adjacent data that we are getting in the point cloud will be not much dense. Okay, I mean, it's not like very dense than a RGB image. Okay, so there are a lot of challenges because if you want to detect a pedestrian from this point cloud, then you have to train it. You have to like label this pedestrian from this noisy data, then you have to train it. Okay, so one of the project that I have heard about, heard while working with CME was like pedestrian detection from point cloud. Okay, that was one project that some of the master student done, which is basically a deep learning thing. Like he actually marked the pedestrian from the point cloud and then trained it. Okay, but it's not easy. There will be a lot of noise that come in this kind of data. Okay, so let me know if you have any questions. After that we can conclude today's session. So next week I hope we can next week I think we can jump into Git. Okay, and let me see if I can cover Docker as well. Okay, yes, so let me hear from you, like if you have any confusion in PCL, let me know. Any question, guys? Yeah.
So regarding applications in which we can apply PCL, we have talked only about where application related lag, where we will be having thinking only that.
Oh yeah.
So when we deal like robotics means will be able to gather data points inside the
Tarun, your voice is actually breaking. I'm not sure it's my issue. Guys, can you able to hear Tarun's voice? Anyone can hear Tarun's voice? I mean,
yes, sir.
okay. It may be my issue then. I think I can hear you, but your voice is breaking. So what you can you repeat it, Tarun?
Yes, sir, no point.
Yeah, sometimes it's okay, but sometimes it's going. Maybe what you can do is you can just comment it. Okay, you can come. Okay, and then I can reply. So like here the connectivity. I mean, there is no issue with the connectivity. Like it's green actually, but when you talk, like the voice is like it's disconnecting sometime. Maybe you can get it from the video, like so best thing is like if you have doubts, you can comment it. Okay, so I can explain in detail. Okay. Okay. Yes. Yes. So that's it, guys. So that's about like the OpenCV PCL. So we can discuss Git and Docker next week. Okay. Hope we can complete that. Then there are some stuff like how to build the portfolio for robotics, all those stuff. Okay. Yes. So thanks for attending. See you next week, and good night, everyone. See you next week. Bye. Bye, everyone.
Thank you, sir.
Bye. Bye.